in this section we'll be discussing another example about absolute and relative error. So here we have the question, what is the absolute and relative errors of this arithmetic operations that are given down here as a and b down here, and then we have to perform the following calculations. That's the first thing, is that we have to find out the exact value of these calculations, and then we have to use 3-digit chopping arithmetic to get the values and 3-digit rounding arithmetic to get the values of these two operations. And then the fourth step would be to compute the relative errors in part 2 and 3. So the first thing that we need to do is to find out the exact values of these operations. So for A, we have 4 divided by 5 times 1 divided by 5. That would be equal to 4 over 25. And I would leave the exact solution to be that itself, but just to write down the decimal part, I'll write it down. So that's 0.16. And then let's do the part B simultaneously. So for part B, we had here 1 over 3 plus 3 over 11 minus 3 over 20. That gives us the value 301 divided by 660. So that would be the exact solution according to me, but then you can also write the decimal values here because those will be required later on now. So we have 0.4560606, and it continues. So now this was part I, that is finding out the exact values for the operations. Now for part 2, we have to find out the 3-digit chopping arithmetic. So basically we have to take these answers here and chop them to 3 digits after the decimal point. So, or you can say 3 significant digits. So here we have just let me use a different color for this step. So here we have 2 significant digits. We don't have the third one, so you can just write it as 0.16. Okay, and for this one here we have 1, 2, 3. So that's until where we'll work out. So we'll have here 0.456. Now we could also work it out here, the fourth step, which said us to compute the relative errors in part 2 and 3. So at part 2 we have to calculate the relative errors for each of them. So let's do that at the same time here. So let's calculate the relative error for the second part. That would be the original value 4 over 25 minus the approximated value, which is 0.16, divided by 4 over 25, and that here will give us a 0 because those are both 0.16 here. And then here we, to find out the relative error, we will take the exact value, which is 301 divided by 660 minus 0.456 divided by 301 divided by 660, and that gives us the value 0.000133. Now let's go ahead and solve the third part. So in the third part we have to do the 3-digit rounding. So this was chopping up here, and then we have to do the rounding now for 3 digits. So this answer will remain the same because we only have 2 digits. So we have here 0.16, and for the third part here we have to take 3 digits and then we have to round. So we check the next number here up, and the next number is less than 5. So in that case we don't change the 6 here, we keep it as it is. So we'll have the number 0.456, and then we will have to find out the relative error for the third step here. But because the answers are same here and the original value is same, so the answer for the second and the third will be same, 0. And for the relative error here, again we have the same values for the second and the third part, so the relative error will also be the same, which would be 0.000133.